In this video, I am going to present about fluidized bed composition, construction details, working principle and advantages. This is fluidized bed composition construction. Here, the first figure at left hand side showing that fixed bed, and second one bubbling fluidized bed, third one circulating fluidized bed. Here the fuel is enter into that side hole and then flue gas exit at the top of the hole. Here the air is enter through the bottom of the hole. From the air circulation with the fuel circulation, the fuel gases can able to generate and move on the top of the fluidized bed compression chamber. Here the third figure showing that circulating fluidized bed, which means there are one more provision provided at the side of the fluidized bed, which is provide that circulation of flue gas so that we can get some more circulation facility from the fluidized bed composition. The circulating fluidized bed composition schematic diagram is shown at the bottom of the figure. Here in the left hand side, cold limestone is located on the hopper, and then both will be come together into hopper, and then the hopper will send the combined coal and limestone material to the furnace of the combustion chamber. Here the air distributor will distribute the air, and also the fluidizing air will be supplied to the flue gas through the furnace, and then the water tubes also carrying the water to convert steam out and through the flue gas chamber. So in that right hand side you can see the preheated chamber, air preheater also located in between that intake of air centrifugal pump and the preheated air zone, and then the flue gases passing through the air preheater, and the finally the flue gas exits the exhaust region. This is circulating fluidized bed combustion chamber simple construction details. Here the fuels is located at the bottom of the combustion chamber. As is removed at the bottom of the chamber by using a small tubes which is represented as us, and then air also circulated through the pipe which is represented in that horizontal wise line, and then L or J valves also located to provide the provisions of air circulating. And at the bottom of the boiler furnace there is a bed of inert material. Bed is where the coal or fuel spreads. Air supply is from under the bed at high pressure. This lifts the bed material and the coal particles and keeps it in suspension. The coal combustion takes place in this suspended condition. This is the fluidized bed. Special design of the air nozzle at the bottom of the bed allows air flow without clogging. Primary air fans provide the preheated fluidizing air. Secondary air fans provide preheated combustion air. Nozzles in the furnace valve at various levels distribute the combustion air in the furnace. This is circulation details about circulating fluidized bed combustion. Fine particles of partly burned coal, ash and bed materials are carried along with the flue gases to the upper areas of the furnace and then into a cyclone. In the cyclone, the heavier particles separated from the gas and falls the hopper of the cyclone. This returns to the furnace for recirculation, hence the name circulating fluidized bed combustion. The hot gases from the cyclone pass to the heat transfer surface and go out of the boiler. Here, the velocity of air causing fluidization depends on a number of parameters like size of fuel particles, density of air fuel mixture. Hence, these parameters are given due consideration while manipulating with airflow velocity for desired rate of the combustion. This is circulation fluidized bed combustion advantages. High thermal efficiency is possible in the fluidized bed combustion, especially that circulating type. Easy as removal system to be transferred for maximum short commissioning and erection period. Fully automated and thus ensure safe operation even at extreme temperature. Efficient operation at temperature down to 150 degrees Celsius, well below the ash fusion temperature. Reduced coal crushing, etc. Pulverized coal is not a necessary here. Reduced coal crushing. The system can respond rapidly to changes in load demand due to quick establishment of thermal equilibrium between air and fuel particles in the bed. The operation of fluidized bed furnace at lower temperature helps in reducing air pollution. The lower temperature operation also reduces the formation of nitrogen oxide by adding either dolomite, a calcium magnesium carbonate, or limestone calcium carbonate to the furnace. The discharge of sulfur oxides to the atmosphere can also be reduced if desired. Thanks for watching the video. Within the presentation I have concluded the steam boiler topics. The next topic we are going to discuss in the part 3 video. Thanks.